Alright, so weights of adult lions normally distributed with mean for 10 pounds, standard deviation 10 pounds. Okay, what percent of adult lions weigh more than 425? So z-score, the value we're considering is 425 minus the mean 410 divided by the standard deviation. Okay, so this is not a sample, right? It's not a sample, it's the whole population, so we do not divide by square root of n. Okay. So positive 2.5 would be over to the right. And we want to know what percent weigh even more than this. Okay, so our z table 2.5, 0.9938 is to the left, but then we want the shaded area to the right, so we'll just subtract from one whole. Okay, so then we want percent, so move this twice. Okay, probability less than 402. Okay, and then we want the probability it's less than this. Okay, so our z-table doesn't go into the negatives, so we would want to reflect this. Okay, so then now looking at positive 0.8, we get 0.7881. But again, we want the area to the right, so we'll have to subtract from one whole. Okay, so probability 0.22119, or if you want percent form. Okay, weighing more than 401. Okay, z-score is negative 0.9. Okay, and this time we want more, so to the right. And then our z-score is negative, so we're going to want to reflect this. Okay, so looking this up on our z-table, 0.90, 0.8159. Okay, and this time no subtracting from 1 is necessary because the z-table gave us the area we wanted. So I'll just convert it to percent form. Okay, less than 434. So positive 2.4 for our z-score, and then we want less than that. So this one we can look up directly in our z-table. 2.4 is 0.9918. Okay, so you could either give that or convert to percent form. Okay, so we got a between problem. So let's do both z-scores first. Okay, so let's look at what area we want now. So we want to be more than 0.3, but less than 1.1. Okay. So to get this area, we could do the 1.1 on our z table, and then just subtract the 0.3. Right, because if you take away the 0.3 from the 1.1, you're left with just this section left over, which is what we want. Okay, so 1.1 on our z table, 0.8643, and then 0.3 is 0.6179. Okay, so subtracting those. So 24.64%. Okay, how much do the lightest 25% of adult lines weigh? Okay, so what am I looking for? I'm looking for the dividing line in which 25% area is to the left, meaning 75% of the area is to the right. Okay, so, well, this would be a negative z value because it's less than half, so let me just reflect it. Okay, so then when I reflect it, currently z is negative, so when I flip it, I'm looking at a positive z, but I know that the true answer will be the negative version. Okay, so I'm looking for a z value which has an area to the left of 0.75. Okay, so 0.75. So the closest value we have is right here, 0.7486, and then that is created by the z value of 0.67. Okay, so that means that over here, once it was reflected back, it would be negative 0.67. Okay, so then the z value equals our unknown minus the population mean over the standard deviation. Okay, so let's solve for our variable. Okay, so then x would be 403.3 pounds. Okay, how many pounds would a lion have to be in order to be in the 70th percentile? Okay, so 70th percentile means that you are heavier than 70% of the rest of the population. So here we're looking for the z value, which has 70% of the area to the left. Okay, so looking for 70 in here. Closest value is 0.6985, which is created by the z value of 0.52. So we set up the z-score formula and solve. Okay, so finally we're comparing a heavier than normal lion versus a heavier than normal elephant. So again, we do the z-score for each. So for the lion, 425 minus 410 over 10 would be 15 over 10, or 1.5. So the lion is 1.5 standard deviations above average for its species. Okay, this elephant So the elephant is 1.4 standard deviations above the mean for its species. So the lion, because its weight is more standard deviations above the mean.